So quadratic is a type of polynomial, and we've been talking a lot about polynomials, but we also spent a long time in the very beginning of the semester talking about quadratics. So this should be a good recap for you as far as methods of graphing and solving with quadratics. So there are three forms that your quadratic could be in. Vertex form. Why is it called vertex form? If the vertex is given to you, that's exactly right. F of x equals a times x minus h squared plus k. What is the vertex? H and k. Thank you. Easy peasy, right? Where is the axis of symmetry in this one? It would be, no, you're close though. It's the x part of the vertex. Remember, that's the line that divides it. So it's x equals h, okay? Next form we have, Robert, if you put that away, please, is what we call intercept form, which is basically just factored form, okay? So it's what you get when you factor it out. And it makes sense. We did a lot of solving, and when we solved, we set each piece equal to 0 to get the individual x values, right? So when I talk about intercepts, which intercepts am I talking about? What points, though? The x-intercepts. That's exactly right. So if my equation looks like this, what are my x-intercepts? X equals what? Q and P. Remember, crosses, most parabolas cross twice. They hit the x-axis 2 times. Okay. All right, those are 2 forms. Do you remember the third form? Yes. Good job. Last and final form is standard form. You remember what it looks like? It absolutely is. It gives us nothing but the y-intercept. Everything else we have to calculate on our own. So when we find the vertex in this one, we first find the axis of symmetry, which is opposite b over 2a. And then we plug in there to find the y part of the vertex. Y'all remember how to do all this, right? Mm-hmm. I'm just kind of giving you an overview because we spent so long doing it in Chapter P. Tell me what A does in all of these equations. Up or down. And now that we've studied transformations, we know that that's due to reflections, right? What else does it tell us? But what else? Aside from positive or negative? Wide, skinny. That has to do with stretches and shrinks, right? And we know that now also. All right, can everybody graph from any one of those 3 forms?
Yes.
What if, let's see. You don't have a pedophore to give me if you lose.
Yeah.
Do you?
Yeah, I need to buy one.
What store sells them?
I'm not buying one. Food line.
All right, then I'll graph each one time. One example of each form. We'll do. What form? Vertex form. When I graph in vertex form, what do I do? Okay, so what's the vertex? 3, 1. It's opposite sign, so it's 3, 1. Okay, so I come here, I graph 1, 2, 3, 1. This is also my axis of symmetry. Now what? Well, for this one, you need to do an easy point. 1 over from there. You could, standard form 0 is the easiest, but since I'm in vertex form, I'm going to just go 1 over. I'm going to let x be 2. When x is 2, what does y become? Ah. 2 minus 3 is -1, but squared becomes +1. 1.5. So 2. One and a half. Yep. Sure. The further you get away from the vertex, the higher it goes up really high, really low, really fast. What's the domain? Yay, what's the range? It absolutely is. Y'all are on it. 1 to infinity. Okay? Remember, this is all review stuff. So I'm going a little fast. I'm not going as slow as if I was showing it to you for the first time. So if you need me to slow down, tell me. Okay. Yes, it's intercept form. It's intercept form because it gives us the x-intercepts, right? All right, so tell me then, what are the intercepts? Negative. Change the signs on them. All right, so that means I have 1, 2, 3, and -1, right? What am I missing? The vertex. How do I find the vertex?
You gotta put those points.
All right, they're on there.
You gotta find the middle.
The middle. How do you find the middle of 2 points? Okay, what if they're not whole exact numbers that come out even that are
Are you supposed to add both of them and divide by 2?
times? Yes? 2 divided by 2, right. Add them and divide by 2. So how do you get the other number? If you've got x and you need the other number, what do you do? Yes, you plug it in for y. I mean, you plug it in to find y. So -2 times 1 plus 1, 1 minus 3. -2 times 2 times -2, which would be, it's +8, right? So we'll go all 1, 2, 3, 4, 5, 6, 7, 8. It's going down. How could I have looked at that equation and known that it was going down from the start? It's a negative on the 2. That's exactly right. That's the worst parabola I've probably ever drawn, but it's okay. What's the domain? Great. What's the range? Close. Switch it around, though, because you want from the bottom up, negative infinity to 8. All right. One more. All right. Everybody's favorite form. That's right. Oh, that's going to be terrible. Let's make that 6. All right, what do you do first? Find the vertex. Oh, I thought that's what you said. What did you say? Okay, I drew my graph. Now what do I do? I thought that's what you said. Okay, find the vertex. X equals what? Opposite B, so 6 over A. So it's 1, right? Now how do I find The y part of the vertex. Fill in, that's right, plug in. So 3 times 1 squared minus 6 times 1 plus 5. 3 minus 6 plus 5, which is what? 2? Negative 3 plus 5 would be 2. Come on, pen. It wasn't right. All right, Jerome's favorite easy point on this one. That's right, 0, because I got my y-intercept, right? 1, 2, 3, 4, and 5. Reflect. Connect. You'll have several problems in your homework that ask you for a maximum or minimum. What does this one have?
It has a minimum.
It has a minimum. Look, where do minimums occur? Look what's happening here.
It occurs at
The bottom, okay? So if you're just given a standard form equation, and I asked you if it has a maximum or a minimum, how would you know without graphing? But what if you didn't graph? What if I just said, does that one have a max or a min? Sure?
A maximum,
Why?
because
That negative in front tells me that the parabola is going to open down. And if I ever have a parabola that opens down, I have a maximum. Right?
Yeah.
If it was a positive, it would be a minimum. That's exactly right. And so if I'm asked to calculate the maximum, all I'm doing is finding the what? The vertex. That's exactly right. Okay, so let's put it in play with an application problem, because that's really the point of all this. Yes.
you know the other question would be like, what is the relative or relative maximum? What is that?
Say again?
The question that we had like before the test, they were like, what is the relative maximum?
Relative. Yeah. That just means if you've got a whole graph with more than one, this would be a relative max. This one's an absolute max. There's absolutely no point higher than that one. This one, it's a turning point. It stops going up and starts going down, but it's not the highest point on the graph. All right, let me give you a little bit of background before I actually show you this problem. When we're talking about business type problems, in other words, I'm wanting to do things like maximize profit or minimize cost. These are some things you need to know before you do those type of problems. So I'm going to give you some little hints and then we'll do a problem. Obviously these are going to be quadratic type problems, or I wouldn't be putting them in here. Which it makes sense if you think about minimum, maximum. First thing you need to know is that most of these problems involve what we call an initial cost. Okay? These are things that you have to pay up front before you start a business. Let's say, for instance, you make pedophores. Okay? Initial cost in that might be your initial setup, where I have to buy the boxes I'm going to put in them. I have to buy the little holders. I have to buy my labels. I have to buy the supplies to make them. I have to buy mixing bowls, things like that. That's all initial cost, okay? A lot of that stuff is stuff you're going to buy one time to set up, and it's not, maybe I should say like the mixing bowls and the things like that you buy one time that you don't have to keep replenishing, right? So that's an initial cost kind of thing, and you'll have that with any business. We'll say a startup cost. Okay, so we always take that into account as we write a model for what we're spending or what we're making. You'll see the word revenue used a lot. What is revenue? Okay. is how much money you take in. That's exactly right. It's not profit, it's what you take in, okay? So it's money you take in. So for example, if I sell, I'll just use Pettifours because that's what's on my brain, okay? And I sell Pettifours for $12 a dozen, and I sell 10 dozen times the $12, my revenue is $120. Does that mean I made $120? No, that means the revenue, the money I brought in from it, I've still got to take into account all my other costs, but that's money brought in, okay? So in general, it's number sold times price. Does that make sense? Yes, Miss McKee, that makes perfect sense. I'm so glad y'all understand. You always have a cost associated with any type of business. It's not your initial cost, because remember that initial cost is like a setup, okay? It's a one-time deal. I don't have to buy pans and bowls and spoons every single time. But, right, I got to buy the stuff to make the product. So that's where my cost comes in. So it's what I spend, what's spent to make the product. Okay, so obviously we have to subtract that out from the revenue to find out the profit. So that's our very last thing you need to know is the profit, which is what everybody wants to know, right? That's what the money, that's our bring home money. That's how much we make. How much we make. So to find the profit, I take the revenue and I subtract out the cost, right? Whatever it costs me to make it, I subtract that out. So let's look at an example. This is part of it, yeah. Yeah. I'm going to use this example because we used it in our scatter plot yesterday. You didn't realize exactly what it was you were graphing in the scatter plot, but we did one that, the scatter plot for the example that we did in class, it was like boxes and, what was it? It was price per box versus the number sold, okay? And we got a linear regression equation for that. Do you remember that?
Yeah.
Yeah? Okay, to tell us that, y'all don't remember that? This is the example that we did where we put it in and then we calculated the linear regression and we got like negative 15,358.93x. Remember I said somebody write this down so you can tell it to me so we can graph it at the same time? Y'all, come on, I know you remember this.
Yeah.
Okay. Huh? This was yesterday. This was yesterday in our notes. Do you remember now? Okay. When we put that whole, it was a scatter plot. This was a list of data. Remember, I put the whole list up there and we all entered it in L1 and L2 and then we calculated linear regression. Oh my goodness. This is revenue, by the way, was what we calculated. Okay. With X being how many boxes we sold, right? So if I want to know, if I want to determine maximum revenue, okay, I need to take this equation and multiply it by the total number of boxes sold, right? So I need to do, I can look at y'all's faces and tell y'all are not with me. Okay, let's rewind. Yesterday, I gave you a set of data. And maybe I should have told you what the data was that you were graphing. There was a price per box, and there was a number of boxes sold. We had like 2.4, 2.6, 2.8. Remember that now?
Yeah.
Yes. Are you sure?
Yeah.
Okay. When you found the linear equation, the regression line, whenever we graphed it, it looked like this.
Yeah.
And there was a line that came down. Do you remember that for real, Jackson? You just saying this.
Hey, good observation, boy.
Okay, so tell me what this is that I graphed then.
That's the boxes.
This is not going where I wanted it to go.
I mean,
X was my price, right?
Yeah.
Y was my number of boxes sold.
So you had that many boxes.
Right. So I could tell how many boxes I would sell based on the price, and that makes sense. If your price goes up, you're not going to sell as many, right? So that's why it's a negative slope. Does that make sense to you? As this number gets bigger, this number goes down because nobody's going to pay $25 for a box of cereal, right?
If it's good enough.
Now, if you were good
Okay, but a lot of people, if you took that box of cereal and you charged $1, you're going to sell a whole bunch of them. But then if you take that box and charge $10 for it, you're not going to sell as many. You'll still have some crazy people like y'all that'll buy it if you like it. But I ain't buying no $25 box of cereal. What?
Do you know much?
About this for just a minute, and I told you wrong. Shh, shh, shh. This is not revenue. What is Y? Y equals this. What is Y?
Y is how many boxes?
How many boxes sold? So to find revenue, I need to do the price times the number of boxes sold, right? Okay, price is X, right? That's what I use for it. So I need to do X times Y. Do we all agree with that to find revenue? Okay. So what I'm going to do, since Y equals all of this, I'm going to put this here. Okay? So I have X times all of this. And I do all this to show you where the equation comes from. 93X plus 73, 622.5. Okay? If I distribute this, all of a sudden, I have an X squared, which is a what? Starts with a Q.
Quadratic.
A quadratic.
so I have a question.
Yeah.
You times X on those sides.
I did X times Y because remember I let X be the price per box and I let Y be the number of boxes that I sold. So if I do X times Y, that would give me revenue. And I know what Y is because Y is that whole equation that I found when I did the... I just distributed. Should this quadratic have a maximum or a minimum? Maximum. And that's a good thing because do you want to maximize revenue or minimize revenue? Maximize. You want to make the most money you can. On your own, really quick, take this quadratic. This has an X on it right here. And tell me what the maximum is. Find the maximum of that quadratic. Do it now. Do it now. You can either use your calculator or you can do your vertex, right? Because that's where the maximum occurs. Y'all can do this. Come on. Oh my goodness.
We gotta get it to be every 2-8 on.
That's exactly right.
We get out of here at 9:30,
It
right?
really is though.
Anybody got it yet?
No, this is number.
Yeah. Yes. Oh, why am I doing that in there? Y'all gonna beat me because I was putting it in the wrong place. Bless you. Oh my goodness, 135. 153. 58.93. I got 2.4 for my x. What did you get?
I got 2.4.
What's that mean? What does x represent?
The box is.
Does it? Does it?
Yes, it does. I'm sticking to my answer.
Look at my graph.
The X.
What's on the x-axis? What is x? Money. The price per box.
$2 and.
So to make the most amount of money, you need to charge $2.40 for a box. If you charge $2.40 for a box, how much money do you make?
$2.40 every box.
Yeah.
How many boxes would you sell? How many boxes do you sell at $2.40? Plug it in and see.
Plug it into what though?
All right, listen, you can do this one of two ways, okay? But you need to understand the problem you're working with. That's the biggest thing here, okay? 2.4 is the number of boxes I sell, right?
Yeah.
If I plug it into this equation, that tells me my revenue, how much money I bring in. If I plug it into the linear equation, all that's doing is telling me the number of boxes I sell, and then I'd have to times it by how much I sold it for, right? So why don't I just kill two birds with one stone and plug into this equation and find out how much money I make?
So you're gonna put 2.4.
Do it. Do it, Jackson. Do it.
Alright. You get my
Is that what you're telling me?
If they priced it for $2.40, look at the numbers we were working with.
But I got a question.
Yeah, remember they were like 20 and 30,000. So if they sell it for $2.40, they maximize their revenue.
How much do we pay for these boxes?
One thing, I'm almost done. I promise I'm almost done. There's two equations that are going to come up in your homework. They are, and you have seen some form of these before. Yeah.
Oh. Does that go with that? Because that's the same exact number.
I know. That's what we just got.
I
Yeah,
know,
we
I'm
were
looking
doing
at-
that example.
Okay, I'm looking to see. And this was 2.4. I'm guessing.
Correct. I rounded a little bit. All right. Two equations. Let me explain both of them to you, and then we will be done. It looks worse than it is, I promise. Okay. Here's what you need to know about each of these equations. Okay. S of t tells you the height of an object in free fall. Okay. This is one of those kind of equations that is always the same no matter what. You've probably done this at some point, I would imagine, in physical science, maybe. Some form of this equation. You know, things fall at a certain rate. It's gravity, right?
I don't think I do.
All right. So here is how you can find out how high it is whenever it's in free fall. T is seconds.
D is this.
G is your gravity. That's right. So it is approximately 32
What's V, velocity?
feet per second. Yeah, it is actually.
I'm smart.
Anything you see with a little teeny zero below lets you know that that's an initial amount. It's a starting amount, okay? So V sub 0 is your initial velocity. And S sub 0 is your initial height.
So, what is number?
These are plug and chug problems.
So half the gravity times the
Are they word problems?
Yes.
time.
So you'll plug it in, it'll say, so this is always the same. Your G is always the same. In fact, we could write this as negative 16t squared. Because your gravity is not changing. You're not going to go to the moon and drop something, right?
What do you mean? Right.
I mean, you're dropping it on Earth, And the force of gravity is the same on Earth everywhere, right?
But you're talking about like where you're on the moon and you just drop something. On
Well,
the moon.
because you don't have gravity like you do here. The
Yeah.
gravity's different, right? You weigh something different on the moon than what you... Why are you standing up here so close to me?
Because I just didn't feel like sitting down.
Okay. This will be given to you. It will say it starts with a velocity of whatever. It started at a height of whatever. That's what goes in for those two values. T is your seconds. That's going to be your variable that's really changing. Okay. What is the height after dropping for 10 seconds? Okay. And then you would just plug in 10 for T. All right. V of T is vertical velocity.
Negative gravity time plus sub-zero.
G, always equal to 13.
Yes. That's your G again. Everything else is the same. Let me just do one example with you and I'll be done because I've lost about a third of you.
No, I'm saying like, for every problem, the letter G,
Yep. Yep.
so every time change the word problem.
Right. Yep. For example, Jerome
Yes.
stands
Jerome stands.
at the top of what?
The Empire State Building.
The Empire State Building. How tall you think that is?
The Empire State Building is probably like a good 12,000.
Here's Jerome. You know they say if you drop a, have y'all ever heard that if you drop a penny from somewhere real high it'd kill somebody, because that's not true.
Yeah, okay. You said that's not true? Yo, who was arguing with me about that would be true?
If you drop a word.
Let me do this quickly. Back to Jerome on top of the Eiffel Tower who's dropping his penny
The
down.
Empire State Building.
Empire State Building, whatever. He's really tall, right? How tall is that?
I said 12,000
Look,
feet.
I don't even know what it looks like.
It's, girl, that's the Eiffel Tower. You just, what's up with you and Eiffel Tower?
Okay. Jerome is standing
I'm
on
about to
top
look
of
it
this
up.
building,
Hold up.
right? And he's dropping his penny down.
The Empire.
All right, the height of the Empire State Building, 1,250 feet,
I think I said 12,000. Wow.
right? I want to know, oh, if he just drops it, right? He just lets go. How far is it in 3 seconds?
All the way down.
Okay, so you think it went 1,250 feet in 3 seconds? I don't know. Maybe it did.
Okay, it's probably like halfway.
I would say it went
It don't have a lot of weight. So they can take that long.
5.2 seconds.
All right,
and
so
got all
let's
the way to
see.
the bottom in 5.2 seconds.
All right, so S of T, -1/2 GT squared plus initial velocity times T plus initial height. So let's see. We know initial height is 1,250. Initial velocity, he didn't have any initial velocity, right?
No.
So that's just 0. Now, if he threw it down, that would have initial velocity, but he just dropped.
Yeah, then it would have definitely been like
This is -32, and we want to know after 3 seconds.
Okay, so if you multiply that, it's going to be 16 and then 9. So 16 times 9.
Positive 16, I'm sorry.
Yeah, positive 16, what you doing?
16 times 9,
144. It's 144.
no, we didn't do this right. I got to delete this. I told you that should be negative. Okay, so look.
But you put -32.
I know, I don't know why.
That's why I said it was
okay, this is
positive because of the
negative. Right.
half.
Okay, now do it. That's my fault?
Dang it.
I thought I was about to have to delete this video.
So now it's -144.
This is -144
Yes.
plus 1,250.
Plus 1250.
That's it?
1106.
So that's how far it dropped down.
Yeah, that's his height. Its new height is 11, so it only went down. That's not